meter, right? So whatever this U thing is, it must have units that are equal to Newton meters. The meter goes up there and multiplies with that. So the units of this U must be equal to Newton meters. And therefore, what is that equal to? That is joules, right? Which we learned in chapter 7. Which kind of makes us now believe that this U has some physical meaning. And it does, okay? So the U has units of energy. And it's the energy associated with that conservative force, okay? So therefore, what the conclusion is, non-conservative forces don't have any associated energy. Conservative forces have an associated energy. We're going to call that potential energy, okay? So conservative force, or conservative forces have an associated potential energy function. Potential energy, sometimes it's written as PE, sometimes it's written as U. Conservative forces have an associated potential energy function. Okay, now let's go one more step beyond that. So what? Big deal. What does that mean? What that means is that whenever you are in some kind of force field that is conservative, you will be able to, objects will be able to store energy in that force field. For example, one example of a conservative force is gravity. Gravity is a conservative force. Okay, by raising this bottle of water, I have now stored potential energy in the force field of gravity. Now, when I let go of it, the potential energy converts into kinetic energy. You see? If gravity was a non-conservative force, there would be no such thing as potential energy. I would raise it, I would let my hand go, and it would stay there. Nothing would happen to it. Or maybe it would go in a weird direction, you know, some kind of weird direction given by the force, right? So if there's no potential energy, then you can't store potential energy in that force field. And when you let go, it doesn't convert into kinetic, you see? So the idea of potential energy is that whenever you have a conservative force, it has an associated potential energy function, and objects can go through that potential energy function, gaining potential energy, losing potential energy. When they gain potential energy, their kinetic energy goes down. When they lose potential energy, their kinetic energy goes up. You see? So as objects go through this potential energy function, they gain and lose potential energy. Okay? When they gain potential energy, their kinetic energy goes down. When they gain potential energy, the kinetic energy goes down. And when they lose potential energy, the kinetic energy goes up. So think of the potential energy function Imagine the potential energy function is a function of one variable, let's say x. Imagine graphing u as a function of x. And imagine the potential energy function has this kind of graph. Okay? the potential energy function is an important function telling you what's going to happen to that object as the object goes through that field. You see? When the object is here, what's going to happen to the object? Okay? Now, what's happening to the object, see, this is the potential energy function, and the object is undergoing, this object is undergoing one-dimensional motion. So, here's the x, here's the origin. So let's say, for example, I'm just going to make some arbitrary points. Let's say this point right here is -3. This point is -2. This point is -1. I'm just making some just arbitrary points here. This is this one here is -2. This one is -1. This one, let's say, is the point 2. This one is 4, and so on, you know. This one is the point 7. Those are the x values that I'm giving, okay? So what happens here, let's say the object is placed at the point, this one will be -5. So if the object is placed, so you're imagining here a one-dimensional, imagine you go to this one-dimensional world, okay? You go to this one-dimensional world and you can only move left or right, okay? And in this one-dimensional world, there's some kind of force field. We don't know exactly what that force field is, but that is the potential energy graph associated with that force field, you see? Associated with that force field. So if the question could be, if I place the object at the point x equals -5, what's going to happen to that object? Okay? What's going to happen to that object? There's two ways of answering that question. What's going to happen to the object? One way is to imagine the object as if it's like a ball placed on a hill given by the potential energy function. Okay? So imagine this is an actual hill, some kind of weird shape. And you place a ball right there. What's going to happen to that ball? Will it go up? Of course not, right? It's going to roll down, right? So the ball will roll down. So if I put the object at x equals -5, the object will move to the left, as given by what the ball would have done placed on that hill, you see? So there's two ways of answering what happens to an object which is placed in the potential energy field, okay? One is to imagine the object placed on that hill like a ball, and then it would roll down. The other way to answer it is to say the force that the object feels is negative the derivative of the potential energy function. Okay? So if the object is placed right here, what's the derivative of that location here? The derivative is positive, right? The derivative of the potential energy function is positive. The force is negative, the derivative, so the force that it feels is negative. So if it feels a negative force, which way does the object move? That way, you see? The force it feels is negative. So the object ends up going to x equals -infinity, you see? What if the object is placed at -2? What happens? Again, there's two ways to answer it. What would happen to a ball that's placed there? Well, it would just go and come back, go and come back, go and come back. And if there's no friction, it would just keep doing it forever. It would go all the way to the same height, and then it would come back, right? So it would oscillate back and forth between -2 and whatever point that is. You see? So the same thing is going to happen here. If you place it at -2, the object is going to feel a force to the right until it gets to some point right here, and then it's going to go back.